In this video, I'll be going through 5 important concepts that you come across when you're using DBT. And if you're new to DBT, if you've just started your first DBT project or you're yet to use DBT at all, knowing these 5 concepts would help you better understand how to use DBT and how DBT works. So the concepts I'm going through in this video are layered modeling, YAML files, incremental models and snapshots, materialization, and lineage dependency. And if you're already familiar with any of these concepts, you're welcome to skip to whichever part you would want to learn. Now, these 5 concepts are important things to know to when working with DBT. Starting with layered modeling. Layered modeling is a very common concept within data engineering. The idea is really just to separate your transformation steps into 3 separate layers. The idea behind layered modeling is really just to organize your project properly and for clear separations of concern. So you have each layer performing a single operation. For our staging layer, it's mostly meant to clean your raw data set. From your raw data sets, you transfer it into your staging layer, and through your staging layer, you perform cleaning inside that layer. And then down to the intermediate layer. The intermediate layer is particularly meant for combining data sources, right? So if you have more than one source of data, this is where you combine those data sources to return a single coherent table, a single coherent layer that will be used in the downstream models. And then we have the maths layer, which is the user facing layer. This is the layer that the end users will come into and pick their data from and go and make use of. Now this is very similar with the medallion architecture, which is literally just the bronze, silver, and gold layer. It's the same thing, just a different stem, right? But is much more. But in DBT projects, we tend to use staging, intermediate, and maths. And it doesn't really matter what you name it, as far as you understand the general principle behind the structure of the project. Your general structure of your project would look something like this, right? So within your models, you generally have your intermediates, you would have your maths, and you would have your staging, right? This is a regular structure of a DBT project. And then within those folders, you now have your models inside. So for here, you can see we have our staging model, Java Shop customers and Java Shop others. And also here, intermediate models, intermediate payments, right? So you generally have this prefix attached to your model. So you have your staging prefix SCG underscore, then the name of your model. That is the idea, so that it helps so it's easily identifiable what layer this model is under. And the same thing for your intermediate. For your maths also, you will most likely have dimension and fact tables, right? So that maths is where you start modeling your data into dimensions and facts. So this is the general structure of a DBT project, and roughly 80% of projects will follow this general blueprint. The next is YAML files in DBT projects. These are common files that you would see in every DBT project. The idea of YAML files is it's meant for configuring how your DBT project runs in your data warehouse. It's literally the settings for your entire project. A wrong configuration in your YAML file will definitely give you problems. So the general idea to YAML files is DBT uses YAML files. You see it across the entire project or across your entire DBT project, right? You would see it inside your models, and you have a higher level DBT file, right? This is DBT underscore project.yaml file. This is your top level YAML file for configuring your entire project. So every configuration you'd want to share across your project will be specified within this dbt underscore project.yaml file. And then if you were to enter into your models, you could have separate YAML files inside those models, right? Which also gives those models their own different set of configuration and settings. So you would have in your math intermediate and staging. Now if we have a look at an actual YAML file, this is what it looks like. So this is your top level configuration file, your dbt underscore project.yaml file. And within it, you have the name. This is the name of your project. And then you have the profile of your project. It's always recommended to just use the same name as your profile. And your profile is really what you use in connecting to your data warehouse, which is another configuration file entirely. So here you have path specification that specifies the paths of your folders. So you would have your folders within your project and you would have your paths specified here. And you would have other configurations to inside your dbt projects.yaml file. So you'd also have configuration for your models at this level. And this configuration simply tells your data warehouse how to build these models within the warehouse. Next, we have incremental and snapshot models. And if you're just hearing those words for the first time, incremental models are simply strategies for your DBT models to load more efficiently than the regular way it is designed to load and transform data. While snapshots are primarily meant for tracking historical data, like slowly changing dimensions, right? So these two models are quite common. You come across it, and they're quite important in DBT. But luckily, DBT makes it very easy to implement these models, unlike a regular SQL. So implement an incremental model in your DBT project. All you do is at the top head of your model, you just add a configuration block and specify materialize equals incremental. And then the key in which your table will use for incrementing will also be specified. You would specify that in an incremental block inside your SQL script. So here's the incremental strategy, and here is the incremental block itself. So this two alone makes your DBT project, it makes your DBT model incremental. It looks very simple, but you have to understand it deeper to get an idea of what is going on under the hood, so you don't end up incrementing at a wrong time, which could duplicate or mess up your data. Now, snapshot models are separate models on their own. So this is a snapshot model, and this snapshot model keeps a record of all the historical data within a particular table. Now, historical data is literally data that changes over time. And then this is where the record is being stored, and this is a snapshot model, and you have the current model. So while you have a snapshot, you would also have the current model that returns only the current and most relevant data. So that's the general idea with incremental and snapshot models. Next, we have materialization strategies in within DBT. Now, materialization strategies is really just DBT telling your data warehouse how to create your tables or your models in the warehouse. So if you're using BigQuery and your materialization strategy specifies a view, it simply tells BigQuery that create this model as a view inside BigQuery. Same thing applies to table, incremental, and ephemeral. In most cases, you're most likely going to be using these three incremental strategies. So your model is most likely going to be a view, a table, or an incremental table most amount of times. And if you're just starting, you would want to keep away from ephemeral strategies for the time being. So a view is simply a saved SQL query and not a stored data itself. It saves your SQL query inside BigQuery but does not create a table. And within your layered models, your staging and intermediate models are most likely going to be a view. So you would have your staging models, you would have your intermediate models, and then you would have your maths models. So we'll call this staging, intermediate, and maths. And because this is the table that is actually needed, that will be queried by the end users, this will be materialized as a table. So a table is the physical data itself stored within your data warehouse. Why these two would be materialized as a view. Now, why? Because this is simply passing your data through the staging to the intermediate to the maths layer, and it doesn't necessarily have to store data within these layers. A table stores the physical data that has been transformed, which we just looked over now. And then incremental strategies, which we just looked over, is a table that processes only new or changed data within your raw layer. So if I were to give you an example, you would have your raw data and you would have your final data, which is your maths. So let's say this is your maths and this is your raw layer. Now, what happens here is within your raw layer, you've been processing data every day, and then you have for first, you have for second, you have for third, and you have for fourth. And then within your maths data, all your data that has been processed is so far stops at third, maybe 3rd of May, right? So in your maths, you have for 1st of May, you have for second, you have for third. Now, a materialization strategy literally checks using a particular column, a specified column, and then it checks your maths layer and sees it doesn't have the fourth. Now, what it does is that it queries from third beyond, and then it goes into your raw layer and sees anything beyond your third, anything beyond third date. It requests for that data and transforms that particular data. So that is literally what incremental strategy is all about. And then lastly, we have ephemeral models, right, which are just temporary models. You're basically not going to be using this any amount of time. Lastly, we have lineage dependency. Now, lineage dependency is not a complicated topic at all. It's really just a graph that shows you your lineage, the lineage of your data using the ref keyword. So anywhere your ref keyword is referenced, the lineage of that data, which is where your data is coming from to where it's going to, would be tracked. And this right here is an idea of your lineage graph, right? This is your model and this is your ref keyword. So this is your keyword, which is referencing from an upstream model, which is staging Shopify orders. And you can see over here, it's the same thing. So it literally shows the lineage of how your data comes in from your source to the definition. That's the idea behind lineage. And you should always know that if you to get a grasp on this lineage, right, for your lineage to work, you would need to use the ref keyword. If you were to query a table or a model directly, you wouldn't have it displayed in your lineage graph. So reference and lineage dependency is an important concept in DBT because it shows you where your data is coming from, where it's going to, and if you want to debug anything downstream, like you have an issue with this final data over here. You can then go to the upstream models, which are the models that any prior model depends on. So here for your fact order lines, these are your upstream models. So you can always come in and check which of these models is bringing about any error of some sort. So guys, those were 5 important concepts in DBT in no particular order. And this is not an exhaustive list of what to know about DBT. There are way more deeper concepts to learn and way more things to know when building a DBT project. So if you're interested in learning more about DBT and building projects with DBT, subscribe to the channel and put on the notification bell icon.